let's say before it was actually 500, right? That is actually what you expected to cover in case something goes bad, right? $500. But then you just have to include all expenses that I will incur as an insurance company. Also have to include the profit loadings as well. So that is actually the adjusted premium. So we are not interested in the adjusted premium. We are saying in this case here, what should be the pure premium, right? Before we do any kind of adjustment in this case, given that you have this information. Anyone? 300. Okay, so 300. And then again, see, Anna said 500. And then Esme said 500. I see. So that is very interesting. Maybe, can someone tell me why they think it's 300 and why maybe they think should be 500? Because I think all these are answers in this case here. And we just have to back up, like, why do we believe 300 makes sense in this case? Anyone want to try? I mean, you can unmute yourself, you can comment in the chat. I think all good. And you can turn your camera on, I think, if you want. So what do you think? Why do you think it's 300 or maybe 500? Anyone want to comment? So I think both of them are answers, right? Because you can defend 300 and you can defend 500. And one way to defend, for instance, 300 is like, however, ABC experience. So this 300 is actually based on ABC experience. So I might say, I think this one is more relevant, right? Because we have to charge premium to this ABC company, not other companies. So why not use the data from their own? And in this case here, 300 seems like more relevant, right? But then someone might say maybe 500, right? And why 500? Because maybe 500 is based on a large data set. Because remember, that is the experience of that insurance company. That insurance company has been in the market for some time, right? So if they've been in the like in the market for some time, so they have more information. So I might say maybe 500 in this case here is more relevant because it bears on large data set, right? And you know the good thing about large data set. So probably 500 make more sense, right? But I might say, no. I think 300 maybe make more sense in this case, right? So, and this is actually where now the idea about credibility theory come into action, right? So how much should be charged in this case here? I don't know. Maybe 300, maybe 500, right? But what should we do? So I'll give you like another example, right? Because this was about the company. So this company started, let's say, without, okay, maybe it started this year and they needed insurance and then they have been in the market. So should we update you, do something like that? So let us think about the other problem, right? This is another, I mean, 5 years, of course, you have more information anyway. So we can forget about this one here. Let us think about this second example. So in the second example, suppose a local authority in the small town has run a fleet of 10 buses for a number of years, right? So this have been like in the industry for some time. So the local authority wishes to insure this fleet for the coming year against claims arising from accident involving these buses. The pure premium for this insurance need to be calculated. That is the expected cost of claims in the coming year, right? So remember in this case here, and of course what we'll be doing in the next slide is all about estimating the pure premium. So pure premium is actually the premium before adjusting for expenses and also profit loadings, right? We sometimes call it office premium. So in the exam, if I ask you, what do you understand by the term office premium? You should be able to remember that office premium is simply the cost of claims, right? It's the expected cost of claims, right? Before we adjust for anything, right? So we have to set the insurance, and the first starting point is like, how much are we expected to cover in case if the accident occurs, right? If we expect to cover 1 million, that is the actual cost that we are expected to cover, right? But remember, we are processing stuff, we are incurring all kinds of expenses, and then we are saying, now let us take that expected cost which we are expecting to cover, and then adjust it for all these expenses, and also add is a profit loading. Why? Because we are doing business, right? I mean, we are not here to make you rich, right? So let us adjust it for these things. Ndio. Lakini kwenye premium, what we're interested in estimating the pure premium. Other things actually comes later. So now suppose you have this local authority, right, which I want, I mean, to like to ensure their buses. So we need to estimate the pure premium. So the data for the past 5 years for this particular fleet of buses show that the average cost of claims per annum for the 10 buses has been this one here, right? So we have some information because this company here in the second example, this company has been in the industry for some time, right? So if you want to estimate the pure premium, now we go back to the example which I showed you before after 5 years, because you have some data from that company. At the same time, you have data from the general experience, right? So this is actually what we have here. We call it collateral data, right? So this is based on the experience, is actually like this one here, right? So the question is, how much should we charge next year before allowing for profit and expenses, right? Just like estimate the expected cost of claims. That is actually what this question asks, right? And again, I think we have seen that we don't know the answer in this case here. We can say, let us opt for the data from the company itself, right? Or in this case here, from the authority itself. Or we can say, let us opt for the data from the industry, maybe, right? Why? Because we know that maybe data from industry, maybe these are large data set, or maybe they are relevant data, right? If they are relevant, maybe we should use them, right? Why we should not use the data from the company itself? I might argue, no, we just have a few data points. Maybe you just have 10 claims. So if you take the average, how can we trust, I mean, 10 data points, right? Maybe it does not make any sense, right? Why not trust, I mean, this from the industry? Because let's say you have thousands of data, right? So if you estimate the mean from here, it makes more sense compared to the data which you have and stuff like that. So you will read this one here that, okay, maybe we can back up this, or we can back up this depending on what we believe. So now this is actually where credibility now comes into action. And more specifically, this is actually what we are going to do, right? So this is just, I mean, an example, right? So this is actually the data from here. So USD could be chosen on the ground that this estimate is based on the most appropriate data. So this was the data from the company itself. So the average cost was around, I mean, 1,600. And based on the, let's say on the industry, it was around this one here. So the question is, okay, so which one should we charge? And we are saying, probably we should estimate what we call the weighted average. So we are taking the weighted average here. We are taking Z, and then we are multiplying by this number here, which is based on the industry itself. And we are taking 1 minus Z, we are multiplying with this one here, which is based on the overall experience, or maybe based on the on a large group, let's say, of buses in that case. So you can see in this case here, Z is actually, it actually like a weight, like a weighting factor, right? Why? Because Z ranges between 1 and 0. And this case here, so you have Z multiplied by this one here, and then 1 minus Z, of course, minus this one here. So Z is actually what we call a credibility factor, right? So it's just like a weighting factor, right? Just, I mean, put some weight here, and then you put some weight here. So we are saying this kind of weight we're interested in this part here is like a trust, because this one here is the data from the company itself, and this one here is actually the overall experience, right? Or maybe from a group of buses or any kind of insured properties, right? So we are saying, okay, then it will be like a fact, like a trust you put here. So how much trust do you have in the data, and how much trust do you have in the collateral data and stuff like that? So that is what we call a credibility factor, right? It's actually the quality of trust we put here and the quality of trust we put in this side here, right? So now what actually follows is actually how can we estimate this degree of trust which we have to put here, and the other degree of trust which we have to put in this side. I don't know if that makes sense, So maybe back to the motivating example, which I asked you at the beginning of this one here after 5 years, because after 5 years, you said maybe we should charge, let's say 500, right? Because this one here is actually based on the experience, right? And then maybe we said maybe let us charge, let's say 300. Why? Because I mean, this one here is based on the data from the company itself, which is more relevant, right? So now we are saying probably a good approach to do is to take the weighted average. So you take Z, you multiply by this one here, and then you take 1 minus Z, you multiply by 500, right? Where Z is actually a number between 0 and 1. So the more the trust you have in the data from the company itself, the more the weight you will place in that company data, and the less the weight, the less the trust you have in the collateral, the less the weight you are going to place in the collateral data, right? So maybe in the other word, what we are saying this part. Of course, it will depend. You will see later why maybe I should put more weight in the collateral and not in the company itself, right? Because sometimes it comes back to how relevant the data from the general experience is, right? I mean, if the data are not relevant, why should you put more weight in that, right? So probably maybe put more weight in the data from the company itself. So that is the general idea behind credibility theory. And we have to figure out now, how should we place the weight? How should we estimate this Z where Z give us the weight in the data and the collateral? So does that make sense or not? Or maybe the motivating example is crazy idea here. So does that make sense or no? So does that make sense? Okay, so I can see maybe from one student, I don't know who is student. Okay, Kenneth said no. Cha said it does. Okay, Zoom user said yes. Yes, Esme, okay. Daniel, yes, yes. Okay, so it seems like, I mean, it makes sense except for one. So I will try, I mean, to simplify maybe this for someone who say it does not make sense, right? Because the idea is very simple here, so I expect it to make sense. What we are saying is, I will use this same example here. Maybe I skipped it, so you did not get it, right? So we had this simple example here, that we had this local authority in a small town has run a fleet of 10 buses for a number of years, right? So the local authority wishes to ensure this fleet for the coming year against claims from accident involving these buses, right? So of course now they have been like in the industry for some time, but now they need to take insurance, right? Maybe I don't know why they decided to take that after some time, but the point is that they want to take some insurance now. So the data for the past 5 years for this particular fleet of buses, which they want to insure, show that the average cost of claims per annum for these 10 buses has been this one here, right? So this is based on their experience, right? Based on their previous experience, previous claims, we know that this company actually, the average cost of claims is around this one here, right? So if we don't have any information, actually the mean is a good predictor, right? If you cannot predict the cost which you have to charge someone, of course you look at the mean, what is the average cost before, and then you say this is a good predictor for what they're likely to incur in the future. But remember, this one here is based on the information from the local authority itself. So we have, I mean, other information here that suppose, in addition to this information, there is data relating to a large number of local authority bus fleet from all over Tanzania, which show that the average cost of claims per annum per bus is this one here, so that the average cost of claims per annum for a fleet of 10 buses is around this one here. So you have these two kinds of information. You have information from the company which want to take insurance, and we know that based on this company, based on their claims from past years, the average claims based only from these companies is 1,600, right? But then you have some experience as well. This is what we call collateral data. So collateral data means a large fleet of buses, let's say across Tanzania, right? So we know that average across Tanzania is around this one here. So we have two information here, based on the company and based on the overall population, right? So now we have to decide how much should we charge? Should we charge based on the information from the company itself or based on the overall population, right? So we are saying, okay, we can charge maybe based on the company, right? And why based on the company? Because the data are more relevant, right? This is the data from the company itself, not from any other else. But we are saying we also have information from from across Tanzania. Maybe this maybe is more informative, right? So if we take maybe the average based on this large experience, maybe we likely to end up with something which is more concrete compared to when we focus only on just a single company. So you might argue maybe one is better than the other, but we are saying in credibility theory, we are saying, no, you should not charge this amount or this amount. What you can do, you can estimate the weighted average. So credibility theory is just, just to estimate the weighted average, right? And if you want to estimate the weighted average, the question is, how do you estimate the weights? Because you have now to place the weight either in the data from the company itself or maybe in the collateral information as well. I don't know if that makes sense. Maybe it will become clear when we move on. If that is not clear, bado, Kenneth? So Kenneth said no. Okay, Kenneth. Kama hujaelewa mpaka mwisho utaniambia, but I believe that until the end this one will be more clear. So I'll now move on now. So this is credibility, right? And if you understand this idea, then of course we are done. Because credibility is simply the weighted average. So kama umeshaelewa hapa, then ushamaliza topic ya credibility. So what follows now is actually how can we estimate the weights, right? So this is more formally. Of course, we are saying if you want to estimate what we call the credibility premium. So remember, credibility premium is a pure premium. So it's a premium before adjusting for expenses, before adjusting for profit and stuff like that, right? It's just, the expected cost. Come on, cost so if you're talking about amounts, then this one is expected cost of claims. Kama gari likipata ajali, afu cost ya compensate for that is 1 million, that is pure premium, si ndio? Kwa kama una expect labda gari litapata ajali, then you say pure premium ni 1 million. Kwa sababu likipata ajali, market, that is amount which you have to compensate. But we are saying we are doing business, so we have to adjust for expenses and make and add profit loading because we need to make profit out of this business. But we forget about that one here kwenye formula. Hii formula ni just pure premium. After adjusting for expenses and also for profit loading, we call it adjusted premium, or we call it office premium. So kuna I think niliuliza hilo swali. I just talked like this one here, nikasema kuna office premium, kuna nini, and then I asked in the exam na wanafunzi walikosa. Kwa I believe wamtakosa that thing, right? So we have that pure premium, and then we are saying the pure premium is actually equal to a premium based on the data from the risk itself, right? And also we multiply with the PC, which is actually based on the collateral data, right? Which can be, from general, from the industry experience, can be maybe experience ya Tanzania nzima, sindio? From the risk itself, tunamaanisha inawezekana maybe ni kutokana na information unaweza kama maybe ni policy from just same policy, kama ni company under that same company. And then we have Z is the credibility factor. So this actually ranges between 0 and 1. This is the weight. So how much weight do you place in one over the other? Sindio? More formally, what tunaandika like this one here, kwa sababu now you see this one it's actually the mean, sindio? The mean x1, x plus x2 plus 4 up to xn. So this one is actually the data from the company itself, right? X bar. And then when you see mu, it does not mean that this is the parameter of the normal distribution. No, it just indicates that it's actually the collateral, right? So from the overall experience, this is actually the mean. Kwa kama unazungumzia kwenye distribution, is like you have the sample and then you have the population mean. You have the sample mean and the population mean, where the sample mean is actually the information which you can get, from the company itself, and this one is actually from the overall population. So naomba mjue jinsi ya kuplay na these terms, kwa sababu itafika kipindi will be talking about the prior and the new information. So the new information like what I explained, I mean, on Wednesday is like now you are here. This is the new information. Is your X1, X2 up to Xn, and this one here is actually called the prior information because this is the experience. Si ndio, kwa kuna scenario nyingi ambazo we can twist this formula here, and I believe it will become more clear soon. Because this is what we call a credibility premium. It's actually a pure premium before you adjust for anything. Okay, so this is what I was saying that, okay, before you adjust for profit and loadings, and then this Z actually reflected how much trust is placed in the data from the list itself. Sindio. Remember Z, this is Z. Remember this one is Z. Z ina corresponding na the mean. Sindio. Ina correspond na the mean, na the sample mean. Sindio. Kwani kusema kwamba Z is actually the weighting factor related to the sample mean. It's actually very important when we start to interpret the parameters, especially Bayesian credibility. Come kumbuke this formula here. You have, I mean, the sample mean, and then of course you have the population. Ukishakumbuka this one here, I think all the questions will be much, much easier, right? So I think I will explain about this one here. In general term, the credibility factor would be expected to behave as follows. The more the data there are from the risk itself, the higher should be the value of credibility factor. Sindio? If you have more data from the risk itself, then we expect the value of Z to be larger. Sindio? Why? Kwa sababu if I go back here, kama nina hizi kama data from the risk itself ni nyingi. Sindio? If you have more data, the more the data you have, the more the trust we can place in this part here, right? So Z should be higher. Sindio? Mnafahamu, the more the data you have, the more the information you can extract from that data. So we say the larger the data you have, right, from the risk itself, the more the higher should be the credibility factor. And we are saying the larger the data, the more the data you have from the collateral, the low then the weight of the your credibility factor should be low in that case, right? Because we don't trust much this part here because we don't have data, right? So if you have more data from the risk itself, then of course you have to place more weight in here. So Z will be larger, right? But if we don't have large data set in this part here, we cannot trust them in this one here, right? So remember, Z is actually the trust you put in the data from the risk itself, right? And stuff like that. And then in this case here, of course, the more the relevant the collateral data, the lower should be the value of the credibility factor. So we are saying if you have more data, right, from the collateral, then of course you should not put more weight in the risk itself. Why? The more the data, right, the more the insight we can draw from the collateral, right? So probably maybe you should put more weight in the collateral compared to the risk itself. Okay, so any question up that point? Kama kuna mtu labda sehemu haiko clear before I move on. Okay, so Kelly said, what if you need to use more than one collateral terms? Yes, I think that is a very good comment. And so I will show you how you can do that by using what we call empirical credibility, because empirical credibility now allow us to collect to actually estimate the credibility factor based on a number of collaterals. So if you have, let's say, one company, you have 3 companies. I mean, I don't know, based on how many collaterals you have, it does not matter, right? But as long as you have the data, you can incorporate that. But we need another framework to accommodate that. We call it empirical Bayesian credibility. I mean, it's not this one. It's not what we are covering today. But I mean, there is an approach which will allow us to do that, Kelly. Hatutasoma in this course here, maybe in the other course, but I'm doing that deliberately because your program has a number of redundancies, so we have to make sure that at least we don't do things now and then you do it in another course and then in another course. Does not make any sense. But we are going to see how we can accommodate that by using the empirical credibility approach. So does that make sense, Kelly? So long story short, ni kwamba there is an approach for accommodating that. Kelly? Okay. Yeah, so let me now move on. So the remaining question now is how do we estimate the credibility factor Z That is actually the remaining thing because we know that we can get all this, maybe these estimates here or this estimate here, right? So now the question is, how do we estimate these weights? Because remember, these are weights. How do we estimate these weights? We know this Z ranges between 0 and 1, but how do you estimate it? So that is actually what we have to do now. So in order for us to be able to estimate Z, there are two approaches which we can use. The first one is called Bayesian credibility. And the reason why it's called Bayesian credibility because it's actually based on the idea of Bayesian statistics. So what we covered on Wednesday is actually what we are going to see how we can leverage in here. And then, of course, the second one, which actually is what I was explaining before, is called empirical Bayesian credibility theory. So it's called empirical. I mean, just in the sense that I think, that anything you see with empirical stuff, it means that you are using some data here, right? So in this part here, we are going to rely on the data, right? But in this case here, we have to rely on a number of a number of assumptions and our prior belief about the distributions, right? So the good thing about this empirical Bayesian credibility is that we can estimate Z based on the data. So you just need historical data, and then you can come up with a good estimate of what should be the weight to be placed in the risk itself and what is the weight should be placed in the collateral. So these two approaches. And of course, this is just, history. Of course, you can read about this one here. So people started, to do this stuff, long time ago. Sindio, you can see this is 1914. Sindio, ilikuwa ni wakati wa World War. So the first World War is when people started to think about credibility theory. Sindio, and then we sijui 1914 tulikuwa tunagombania uhuru, sio? Hata bado hatujaweza kugombania uhuru, sio? So people were still, we actually were trying to develop these ideas in 1914s and stuff like that. So, like kuna some more development. Of course, I'm not teaching history, but you can go through this one here, just like a motivation that this has been done over and over again. But I think one prominent figure in this area is Ballman. So Ballman, I think, is the one who developed, empirical Bayesian credibility, which now I think is is more relevant because it's actually the one which is actually used to estimate premiums in the real world. So we have, this 1967, and then they extended the model in 1970s. Of course, this is called empirical Bayesian model 2. Yeah, don't worry much about this one here because I will not cover in this course. So of course, if you want to go in detail, there is this book by Ballman and of course this Gisler. It's called A Course in Credibility Theory and its Application. Of course, it's a good book, but if you want to extend maybe the approaches later, but nowadays, at this level, I think, it's not very important, right? But you can see the idea in the cover here that, okay, you have information from the risk itself. This can be, let's say, information from the company which want to take insurance. So you have information from that. So it's just a single company. And then you have, let's say, many companies in here. And the question which remains now is how can we assign weight to this part here and also this part here, right? So if we are saying, if we are going to assign alpha in this part here, then of course the remaining weight should be placed here, right? But how much should we place here and how much do we place here, I think is actually the question of interest in this case. Yeah, so again, you can read this one here, but I don't recommend it for the time being. So let us start with the first approach of estimating Z, which we call it Bayesian credibility, right? So we'll allow questions after here. But again, if you remember from Bayesian statistics, this was actually the starting point, I think. It's actually the starting point. It's not relevant now because we need to make a number of assumptions about before we can estimate Z, right? So the Bayesian statistics provide a natural way. This is actually the question I was responding on Wednesday. I don't know ni Kevin au nani aliuliza ili swali kwamba Bayesian statistics provide a natural way to compare premium rating information from two sources, the risk itself and the other similar risk. So this is what we have seen before kwamba if we're going to leverage on Bayesian statistics, we can combine informations. We can combine the new information which we have now and let's say information which we had and experience which we had before, right? But we can talk in terms of risk itself and also the collaterals. So, just, I mean, remember the context. You can play with the context in this case here, right? But you have weight which you can place in the risk itself, and you have the weight which you can place in the collateral, or you have weight which you can place in the new data, and the weight which you can place in the prior information and stuff like that. So Bayesian statistics allow us to combine that two kind of information, right? So we are going to see how we can implement this approach by using two key methods in this part here. So we are going to see what we call a Poisson gamma model. So Poisson gamma model, I hope you remember, I think we did this at some point on Wednesday, and we saw how we can combine this, how we can derive the posterior distribution when you have a Poisson in the gamma distribution. And this model here, the combined model, is very useful when you want to model claim frequency, right? This is the claim frequency, not the amounts. We are saying if you want to model the frequency, of course, you can see this Poisson. Poisson is actually for modeling discrete variables, right? So of course, we're talking about the frequency in this case here. So it's a good model when wanting to when you want to model the frequency, right? And then we're going to see the other model, right? Which is the normal model. So the normal model, it means that you just combine the two normal distribution models, and this is very useful when trying to model the amount of claims. So we're going to see how we can implement the Bayesian credibility by using normal model and what we call Poisson gamma model. Okay, so this is how we are going to see it now, right? So it's a very simple question, and I will ask you this first question before I switch to my iPad. Is that you have consider a risk for which is the number of claims each year, which we are going to denote it by n, right? And n is just for the number, right? So this n follow a Poisson distribution with parameter lambda, right? But remember, because we are talking about Bayesian framework, we are assuming this lambda to be a random variable, right? So because it's a random variable, we're going to assume that lambda is going to have a distribution. So the value of lambda is unknown, right? Our prior information or belief about lambda is summarized in the prior distribution like this one here. So remember, we have started with the Bayesian statistics here, Bayesian credibility, right? Now, we have studied with Bayesian credibility, you have to remember that we talked a bit about the prior and the new data and stuff like that. So we are saying if lambda follows the gamma distribution with parameter alpha and beta, where alpha and beta are known parameters, can someone tell me why alpha and beta should be known? Why alpha and beta should be known in this case? Yes, anyone? Yes. So why do you think, I mean, lambda should be known in that case? Of course, is an assumption, right? We are making, but why do you think that is reasonable? Yes, Yvonne, yeah. To estimate the premium. Okay, yes, I agree. We need that assumption to estimate the premium, right? But remember, uh, okay, so we can implement this model before I actually comment in what you posted. Um, so remember, we can use this model for different purposes. We can estimate the number of claims. We can estimate the like the pure premium, like what we have said. So in this case here, because we are using Poisson model, we are trying to estimate the number of claims because we're using the Poisson gamma, right? Of course, you can use it for estimating the amount of premium, which we're going to see how you can implement by using the normal model, right? Yeah, so that was just, I mean, a quick comment. But my question is more about why do you think the assumption about alpha and beta being known actually makes sense in this case? Yes, anyone else? Anyone want to add on what Ivan said? Yes, anyone? What is happening? I'm trying to share my screen, but so sorry, I don't know what is happening.
Because it's a
Yes. Who is this? Sorry, give me one minute. I just want to share. Uh, okay, so I think now it makes sense here. Uh, okay, so we were here. Someone I think was trying to comment this, so I'll give you time to respond. So I'm saying, why do you think this comment here? Because we are making an assumption that these two things here are no. So my question is, why do you think that that should be the case in that case? Yes. Someone wanted to comment on this. Kuna mtu alianimute hapo akawa na comment, nadhani nilimkatisha. I don't know who was that. Okay, so I can see in the chat, I even say, okay, Anna said, we have no data to find them. Okay, so so we have no data to find them. So we have to make an assumption that they are known. Okay, I think that is a good response because our variable is lambda. Yeah, so our variable is lambda, I agree. So it's a random variable, and we are making an assumption that this one here has a distribution, which is a gamma distribution. Because we need to determine the lambda parameter. Okay, so Kelly and Lovelace, I think they agree that we have lambda and then we have to determine the lambda parameter because alpha and beta is, yes, Ismail. Yeah, I think that is what I was looking for, right? Because alpha and beta is our prior belief, right? Is our prior, right? So if this is a prior thing, it's something which you have to know, Cindy. I told you that one of the challenge probably, or one, I don't know if the challenge or what, but if you're using the Bayesian statistics, you need to have prior belief, right? So if you have prior belief, it means that you know something. This should be known. It means that the prior belief about lambda should be known. So we are not interested in here, right? We are not interested in estimating alpha and beta now because it does not make any sense for something to be prior and unknown, right? The fact that it is private means that we know all these parameters, alpha and beta. So you'll be seeing your ability. The question is, okay, can we really, figure out, the values of alpha and beta in this case, right? So thank you, Ismail, for that. So I hope that makes sense for others. So Esme said, for Bayesian to work, you need to have, yes, you need prior, yeah, you need prior information, right? So this is prior information. So it's something which you have to know before, right? So if you have to know before, then of course we expect alpha and beta to be known in this case. That is why we are making that assumption, right? So now we are saying, without any data from the risk, what is your estimate of the value of lambda? Okay, so now suppose you don't have any data, right? So what is going to be the best estimate for the value of lambda? So if you understood, what I said before, this question should be very simple for you. So without any data from the risk, what do you think is estimate of lambda? Anyone? So I'm asking about this part here. So what do you think should be the estimate of lambda if we don't have any information from the risk itself? Yes? No one. I say no one. I would have a quiz for this one here. So we don't have any data. What would be the good estimate for lambda? If you don't have any information from the risk itself. Use a card. Anyone? I say, but if this is not clear then kama hamjaelewa hili swali basi maanake hapa kuna hamjaelewa credibility nzima na Bayesian statistics. Because the idea is very simple. I said in credibility, we want to combine two kinds of informations. You have from the risk itself, and then you have from the collateral, like this one here. So in this part here, the collateral in this case here is prior. We have prior belief na tuna data from the risk itself, which is actually X. So we are saying, if you don't have any other information from the data, you don't have any other information, then your good estimate will come from your prior experience, right? Because you have the prior is this one here, right? So the good estimate in this case here is the mean of the prior. What is the meaning of the prior? The meaning of the prior is you have a gamma, right? So the meaning of gamma is alpha or beta. Done. If you don't have data, then of course you have to rely on your prior experience. And our prior experience here is that lambda follows a gamma distribution with parameter alpha and beta. So the good estimate in this case here is actually the mean of the prior distribution, which is alpha over beta. Then you are done, right? Because now if you look at the second question here, so this is actually what you have to do, this part. Because if you look now at the second part, is that now suppose you have observed the risk for any years, right? Just like the example I gave you before. Now suppose you have observed the risk for any years, and the number of claims in successful years are this one here. So we have claims in this one here. So now we have observed the data, right, during this period. So show that the Bayesian estimator of lambda, right, there is very important sentence here that with respect to square error loss is in the form of credibility estimate. So now what is going to be the estimator in this case here under this framework? What is going to be the estimate of lambda if you are using, I mean, the square error? Kind of information in this case here, we have the data from the risk itself, and then we have some prior information. We said on Wednesday that we can combine these informations because we know the posterior distribution of lambda given x is simply equal to the likelihood, which we take the product from I is equal to 1 up to n of which distribution do we have? Because the number of claims, they follow a Poisson distribution, right? So our x's follow a Poisson distribution. So we say we have this one here minus lambda divided by x factorial, and then we're going to multiply everything with the gamma distribution. So the gamma distribution, remember this one here is with parameter alpha and beta. We know this is beta, alpha, and then x alpha. No. We don't have x here, right? Because this is the prior information because our x is lambda. So we have lambda, alpha minus 1, and then e minus, this is supposed to be bx, but is going to be b lambda, right? Because this is actually not x distributed with alpha beta. What is distributed here is lambda. So lambda is supposed to take the place of x. And now we are saying, now it's very easy. We can combine these two distributions. And of course, we did this. And then we said, okay, we are going to write this one here as a proportion and take all the constant things out. So we said we are going to remain with lambda, summation of x, I, right? And of course, we're going to combine with this one here. So you're going to have plus alpha, and then subtract 1. And then, of course, we are going to remain with e power minus lambda. So you have lambda here. So this will be lambda n. So we're going to remain with n, and then plus beta, and then this is power lambda. So we can see that the posterior distribution in this case here, right, is actually a gamma distribution. So it's a gamma distribution. This is the sound is actually the symbol for gamma. So it will be alpha plus this one here. This is my alpha parameter. And then, of course, the beta parameter is n plus beta, right? This is the posterior distribution, right? So the posterior distribution is like this one. So just, I hope you remember this part here. But remember, we have to show that the Bayesian estimator of lambda with respect to square errors is in the form of credibility estimate. So we are saying, okay, we know this is the distribution, but under the square error rows, the estimator, right? The estimator in that case here is actually the mean of the posterior distribution, the mean of the posterior distribution. But the mean of the posterior distribution in this case here, it means that, remember, this is gamma, and the mean of gamma is simply alpha over beta. So what is my alpha? This, my beta is this one here. So we are going to have the mean, in this case here is alpha, oh, sorry. Okay, so the mean in this case here will be, okay, so my alpha is alpha, and then plus sigma xi divided by n plus beta. All right. So now I have to show that this estimator here is in the form of credibility formula, which I showed you before. And what is the formula? The formula, if you remember, I said the formula is z x bar plus 1 minus z, like this. So the question asks you, okay, can you rearrange that estimator of lambda to be in this form? Can you do that? So that is actually what we have to do. So what I'm going to do now, I'm going to say, okay, lambda estimate is equal to, first of all, I'm going to separate the part, because you can see that we have this this part here. This part is for x's, right? You can see this bar part. So this is not, is this simply, I mean, the overall mean or the population mean, right? So what we can do now, we can do like this one here. I'm going to take that estimate, and then I'm going to rearrange it like summation of xi, and then divided by n plus beta, and then plus alpha divided by n plus beta, right? And then I'm going to say, okay, I want this part here to be the mean. I want this part here to be the mean, right? X bar. So what am I going to do? I'm going to multiply this part here by n over n, right? So multiply this one here by n over n. So we can multiply this one here by n divided by n. So if we do that, of course, you'll be able to see that this one here will be equal to n x bar divided by n plus beta, and then plus, and this part here, I'm going to multiply, this part here, I'm going to multiply by beta over beta, right? So if we do that, oh, why? Ngoja nitoe headphones. I don't know. Can you hear me now, Irene? Au bado nimetoa headphone, I don't know why, kama sauti ina decay. Can you hear me? Irene, can you hear me? Au ndo kabisa isikike? Okay. Sorry for that. Maybe kwa sababu ninaweka, labda kwa sababu ninaangalia upande. Anyway, I hope this makes sense. So what I have done here ni kwamba in this part here, I just want to find this x bar. I just want to find this this x bar here. I just want to find this x bar here. So I said multiply by n over n, and in this part here, I want to find the overall mean or the population mean. So I'm going to multiply by beta over beta, right? So here I'm going to have any x bar, and then in that part, the other part, I'm going to have now beta divided by n plus beta. And then, of course, I'm going to have alpha over beta in here. Or maybe let me write like this one here. Sorry, this is the same thing with full kama umeandika. but I just want to show you this, what I'm trying to do in this case, because now here we are going to get n divided by n plus beta multiplied by x bar, right? So now look at this one here, right? So if you look at this two part here, this part here, and then look at this part here, right? Now what I've done here, I have rewritten the estimate in this form here. Z x bar plus 1 minus z, and then the mu. So the mu in this case here is actually like the population, but in this question is not the population actually, it's something which we know from prior experience. From prior experience, we have a gamma distribution, and we know the gamma distribution, the meaning of the gamma distribution is actually alpha over beta, right? So you can see now I've rearranged. So in this case here, we know what is z. Our z in this case here is equal to n divided by n plus b. So does this make sense? Yes or no? This was the question. Now, suppose you have observed the risk for any years and the number of claims in successful years are x1, x2 up to xn. Show that the Bayesian estimator of lambda with respect to square errors is in the form of credibility estimate. So we have seen that this one here is in the form of credibility estimate. Is actually in this form here, right? So we are saying now our z is simply n divided by n plus beta. So does that make sense? Why other z has beta, not n? Why the other z does not? Okay. Why the other? Why the other z has beta, not n? Not n. Not okay. So Sekela, that is actually like the check, because if we want to check if the way you have rearranged your formula is correct, is actually to ask yourself if this one here is z, right? Because we are saying this one is z, and we are saying this one here is 1 minus z. So you can check, is this true, right? Because you can say, okay, if my z is equal to n divided by n plus beta, then what is going to be 1 minus z? 1 minus z, it means that it will be 1 minus n plus beta, right? So if you take this one here, of course, you'll get beta divided by n plus beta. So this thing is true, right? Because z is n plus beta, and then 1 minus z is actually beta divided by n plus beta. And if you sum this part here and this part here, of course, you should be able to get 1. Why? Because we know we have some trust in one and the trust in the other. The sum of that should be 1, right? Yeah, so that is actually how it works, right? So that is a good question, Sekela. I mean, you can check if, you have done that correctly by checking, oh, this is 1 minus z and this is, yeah, stuff like that. Okay, so any other question? So if we have understand this one here, I think, for the case of normal model is going to be straightforward, because the idea is the same. We have to find a way in which we can rearrange the formula and then determine z. Because remember, what is challenging now is actually how can we determine our z? And we have demonstrated this one here by using a Poisson gamma model. So now we are asking ourselves, okay, what if you have other model which you can so let me show this example here. So this question here, I've asked a number of times, not exactly the same question, but the question in this nature. Because I think it's a good question for you to think about the weights. Na most of the time nilikuwa nauliza hili swali last year, wanafunzi walikosa sana. I don't know, walikosa sana this. Of course, not exactly the same question. You will see this maybe in the past paper. Not the same question, but it's a good question because now you have to think, you have to integrate your knowledge about variance, and see how that thing is related to Z, right? So we are making an assumption. So it's actually the same question, right? Except now we are saying, suppose you have the values. So we are saying the number of claims each year from a risk has a Poisson distribution, right? Hii hapa ndo assumption ambayo tulifanya kwenye ile swali, Poisson distribution with parameter lambda. The true value of lambda is 150. Okay? is 150. But this is unknown to you. So any is like we are saying we know the answer. The answer is 150, right? But suppose this is not known. You don't know this. You're just trying to estimate this 150. You don't know it, si ndio? Kwa hii 150 mnaiona hapa, lakini we have to make sure that we don't know it ili tuweze kutoa nani comment tukilelate na true value. So this is the true value which we don't know. But this is unknown to you. Your prior information or belief about lambda, you have some belief hapa kwamba my lambda probably it follows a gamma distribution, right? This is your prior belief where alpha and beta are known parameters. Hiki tuwezi ukakimbia kwa sababu if it's a prior, then we should know it. Si ndio? Haiwezi kawa kitu prior and you don't know it, right? So we have to make sure that an assumption that. So we are saying consider two cases. The first case assume lambda alpha ni 100 na beta ni 1, and then the second scenario assume alpha ni 500 and then beta ni 5. So we are saying estimate the value in the following table and comment on the results. So before I move on, I can simply say, okay, based on the prior distribution, I can see here, for instance, the mean, sub the mean unafahamu, the mean ni alpha over beta, sindio? Kwa the mean nikiangalia hapa juu ni 1 juu ya 100, sorry, ni 100 juu ya 1, ni 1 juu ya 100, ambao ni, sorry, 100 juu ya 1, sorry. Ni 100 juu ya 1, which is 100, and then this part here, I mean the mean, the same, ni alpha over beta, sindio, ambao ni 500 juu ya ngapi? Juu ya 5, right? Juu ya 5, ambao in that case here is actually 100 again. So these two distribution, they have the same mean, right? But now go back to this one. Before we do anything, you can see this is actually the true value. The true value. And remember, we have some prior information here kwamba the true value could be a gamma distribution. Now to substitute, we can see the mean is 100. So you can see the mean, our prior belief is somehow far from the true value. Remember, we don't know the true value, but we are assuming, based on the prior knowledge, it can be 100, right? It's not. The true value is actually 150, right? But we have some prior belief because 150 is unknown to us. We don't know, right? Because this is how prior work. Prior ni kwamba you don't know the actual value, but you're saying probably based on the previous experience, it can be 100. But we are saying you can try to combine maybe some current information in the previous one, because previous we know is 100. Maybe let us combine with new information so that you can get closer to the true value, which is 150. So just remember this distribution. Both of them, they have the same mean. Okay, so now let us move to the question here. Estimate the value in the following table and comment on the results, right? So I will estimate some few for you, and then you will try to finish this on your own. But you can see here now, sindio? Sasa there is nothing tricky here kwa sababu manake data ambazo umeanza nazo, sindio? Umeanza data from 2015. Kwa make this is like year 0, this is year 1, year 2, year 3, year 4, year 5, year 6, year 7, year 8, and year 9. That stuff. So what we can do here to estimate Z, we know that because we are talking about the Poisson gamma, we have already estimated our Z. We know Z if we are talking about these parameters n divided by n plus beta. So we can say that, we know Z is given by n divided by n plus beta. But ili kupata this first number here, then of course we have to say our Z will simply be equal to n. So our n in this case here is the starting point, right? Our n should be 0. Right? We don't have any data in this case here. We don't have any prior data. So we are saying Z will be equal to 0 divided by 0 plus beta, right? Which is equal to 0. So our Z in this case here is actually 0, right? So it's actually 0. Which makes more sense. Why? Because remember our formula says credibility premium is given by Z x bar plus 1 minus Z and then the prior or the collateral, right? So you can see that we are saying if we don't have any data from the risk itself, because this is year 0, it's the starting point. So you don't have any information about the risk itself. If you don't have any information about the risk itself, then you cannot put any trust here, right? So this one here should be 0. Why? No data means that we have to put all the trust in this part here, meaning that 1 minus 0, it will be 1, right? So we are putting all the trust in the collateral. Why? Because we don't have data. It's just the starting point, right? So now you have here, it will be 0. Your Z in this part here will be equal to 1. Yeah. Now the estimate of lambda, we know the estimate of lambda is given by lambda is equal to this one here, Z. So if you are here, it means that you're going to take 0 multiplied by x bar, and then plus 1 minus 0, and then the mu. So what is the mu? Remember the mu, right? In both cases, the mu is simply alpha over beta. This is the mean of the prior. So in that part here, we know that the mean is 100 in both cases. So we are going to multiply by 100 in that case. And you can see that if you estimate there, you are going to get this part here is 100, and also this part here is actually 100. And then you move on, because now if you move to the second part, if you move here now, right, what is going to happen? Maybe I can put it, Z is the same thing, is n divided by n plus beta. But at this point now, we are saying, oh, our Z will be equal to 1. So we have one, we have one observation in this part here, because we have 1 year data, right? So we are saying, okay, take 1 divided by 1 and then plus beta. So beta, remember, is for the first case is 1, for the second case is 5, right? So is 1 divided by 1 plus 1, right? So your Z in that case here will be 1 over 2. Right? So you move here again. So to get this value here, you just substitute here again. You substitute, in this formula. So your Z now is 1 over 2. And this one here is again 1 over 2. So you can see that in the first year now, because you have data, you can put some trust in X, which is half, and also you can put some trust in actually mu, right? Which is the collateral or the prior information, right? So the more the data you have, you'll see that your Z will be going up. So we are saying Z is an increasing function of n, which makes more sense, because the more you correct the data, the more the trust you can put in the risk itself, right? Why? Because you have more data from that risk. So why not put more weight in that, right? So that is actually how it goes. I don't know if that makes sense. Mtamalizia this thing kama exercise, unless kama kuna swali, maybe something which is not clear. Kabla skip part. Sorry, I have a question. What if I interchange the position of Z and 1 minus Z? No, that will be wrong, right? It will be wrong, right? It will be wrong. Manake, what you are saying, okay, instead of me writing, let's say, kama nimekula swali lako ni kwamba, we know that Z x bar plus 1 minus Z and then mu, right? So if you do like this one here, if you say, I'm going to exchange this thing, kama nikola swali lako kwamba you are going to swap this thing here, so you're going to have this, and then you're going to have this. So you're going to have 1 minus Z, and then x bar, and then plus Z, and then mu. This is wrong, right? Because this is alpha over beta. This is wrong. Why? Because we expect one thing. Of course, there are other things, but think about Z, because Z is n divided by n plus beta, unless if you swap everything, right? But if you swap just these positions, then think about Z, because what do we expect about Z is that as n goes up, as n goes up, right? So as n goes up, we expect Z also to go up as well. Why? Because n is the number of observations, right? So the more the number of observation you get for the risk itself, we expect more weight here. More weight should be placed in this part here because you are getting more data. But now if you swap this, you can see that, of course, Z will go up. But if Z goes up, of course, this part here will go down, right? So the more the data you collect, the less the weight will be putting in X, which is not what is expected, right? The more you correct data, right? Because the only reason why we have to combine these informations, because we don't have enough knowledge about the risk itself. Kama you got knowledge, enough data, you have millions and millions of data. Why should you worry about the collateral? We are saying if you have fewer data points, maybe try to combine with some experience as well. Like if you have more data, of course your Z should go up. Z going up, it means that you are giving more weight. Si ndio? Naomba udia kwenye kusolve hilo swali hapo. Sasa sijui swali rudia kusolve hilo swali hapo. Swali lipi? I don't know kama nimeelewa hilo. Table. Okay, table. Okay, I get it. May you repeat, I got lost since you started dealing with the table. Okay. The table is very easy. Maybe nimuulize kwanza Ismail. Does this make sense kitu tunachoongea hapa? Ismail. Yani unless you swap everything, but if you just swap, I mean this Z and kwa sababu this is zina maana kwa sababu kwenye Poisson gamma you have this one here, you have this part here. So if you have this part here in Poisson gamma, what we are making here an assumption ni kwamba as n goes up, n goes up. Of course, I will explain other parameters. Z should also go up, meaning more weight in what? More weight in Z, in the data itself, right? Or more trust, I mean. But if we swap, I mean, it's the opposite. It means that the more the data you have about the risk itself, I mean, the less the way to place in the risk itself. So this is wrong, right? This is wrong. So don't do this. Okay, so let me clarify a bit about the table here, right? Seems like watu wana maswali hapa kwenye this table. So I'm going to remove this part here, right? This part here. Okay, so this part here is very simple. Let me clarify this one here. Is actually very simple. Why? Because we need two things. We need to estimate what is Z, and also we need to estimate the estimate. This estimate here is kwenye formula ndio ambayo tumeandika kama credibility premium. Because is the estimate of the parameter. Because the parameter is something which we don't know. Sindio? Kwanza kwa number of claims, kwa ni claims amount. That is actually what we want to estimate. So we are saying, based on the Poisson gamma framework, we know we can get Z because Z is estimated by taking Z is equal to N divided by N plus beta. What is N? N is the number of observations. And then of course we have lambda. So lambda is actually the parameter of interest. So this is actually our CP. So we are saying lambda now is given by Z multiplied by this one here, plus 1 minus Z, and then of course, I multiply by mu. But mu, I told you that is actually the prior information or is a collateral information. So in this part here, mu is actually alpha over beta, kwa sababu nazungumzia kuhusu Poisson gamma. So now we know that the meaning of the prior distribution, in this case here, is alpha over beta, kwa sababu we have a gamma distribution. So then I said, okay, well, what we have to do now is actually, we have to solve this. So, nikaanza na this part here, nikasema kwamba let us start with estimating Z, sindio? Let us start with estimating this part here, and then maybe we can also try to estimate this part here, or maybe this part here as well, or maybe try to estimate this Z here as well. So I'm saying, ili kupata hii part, this part here, Z ya kwanza, sindio? Kwanza lazima uelewe kwamba, hapa manake, this is the first year, sindio? Because you don't have any other observation here based on from the collateral. Kwa sababu you can see huu ni mwaka 0, mwaka huu ni mwaka wa kwanza, huu ni mwaka wa pili, huu ni mwaka wa tatu, mpaka mwaka wa mwisho like that. So we are saying, kwa sababu formula Z is equal to N divided by N plus beta, then tukiwa hapa, our N is 0. We don't have any observation up to this point, sindio? Kwa hiyo take 0 divided by 0 plus beta like this. So this one will be 0. Right? So we are saying our Z in this part here, right? Our Z in this part here is actually 0. Right? So then we are saying, okay, the estimate. So the estimate now, itakuwa equal to N, itakuwa ni this formula here. You take Z, multiply by X, and then 1 minus Z, and then of course, multiply by the mean. So the mean is alpha over beta. Sindio? Because we are saying now, lambda itakuwa is equal to, this is lambda maybe 0 niweke hivi hapa. Ili nisiwachanganye. This is Z is 0, this is lambda 0. So we are saying this will be equal to z. So my z nimepata 0, make multiply by the mean. I don't have to worry about the mean kwa sababu sina hiyo value, si ndio? And then of course I have to plus this one here with 1 minus z. Z is 0, si ndio? Multiply by alpha over beta. Alpha over beta ni 100, si ndio? Kwenye kesi zote mbili kwa sababu remember alpha over beta, alpha ni 100, beta ni 1. Kwa hiyo utapata 100. Si ndio? Kwa hiyo utapata alpha naught in this case here is equal to 100. So we are saying the value here is actually 100. Now ukienda hapa ni the same thing kwa sababu hii hapa ni estimate nyingine. Remember tuna two cases. Maybe pia ni clarify hapa. Kuna assumption ya kwanza ambayo tuna make hapa ni alpha is equal to 100 na beta is equal to 1. Na kesi ya pili ni alpha is equal to 500 na beta is equal to 5. Si ndio? Kwa hiyo hii ni table. Hii inani part ya kwanza na ni capture ile na ni gamma ya kwanza ambayo ni 100 kwa 1 na hii ina capture ile gamma ya pili ambayo ni 500 kwa ngapi kwa 1. Kwa hiyo kuna assumption mbili hapa ambazo tunazifanyia estimate. Then after that unaendelea, si ndio? Maana utaendelea manake na ile ya pili na ya tatu na hiyo. I don't know if that makes sense. Ukishaelewa tu ya kwanza basi, manake inayofuata your n will be 1. Si ndio? Maana hapo inafuata hapa unasema estimate z1. Z1 itakuwa ni 1 divided by 1 plus beta. Si ndio? Beta tunayo tayari kwenye kesi zote mbili. Kwa hiyo you just get that. So does that make sense, Daniel? Daniel? Daniel, does that make sense au bado? Okay, great. So this table here nimeshawajazia hapa. Kwa hiyo go and then try to solve this. Kwa utaona Z estimate and stuff like that. Kwa hiyo you will have many of these values. Why not use the value of NI? No, NI is actually what we are trying, right? is actually what we are trying to estimate in this case. Kwa sababu n ni x's. Si ndio? N ni the number of claims. Si ndio? The number of claims. Ni the number of claims. Kwa maana ushakuja hapa tunaitumia hapa. Tunaitumia hapa. Umeona hapa? Ni kwa sababu sienda mwaka wa kwanza. Si ndio? Nimeanza mwaka 0. Mwaka 0 hii 0 times x bar inakufa, si ndio? Ukishafika huu mwaka wa kwanza hapa, ukishaenda mwaka wa kwanza it means that you need to estimate x bar. But what is x bar? Maana ukiwa mwaka wa kwanza hapa ambao ni this part here, maana kupata x bar utachukua 144 jumlisha 144 divided by 2 which is the mean. So n zinatumika, si ndio? Sijatumia n hapo ni kwa sababu ya nimeanzia kwenye 0, kwa 0 times the mean itakuwa ni 0, si ndio? So we don't need to estimate the mean. But the more you move on, of course you have to estimate you have to use the NIs. Kwa sababu hizo ndo estimate zenyewe. So we are combining the data because hizi ndo data ambazo nao unapata data. Mwaka 0, mwaka wa kwanza, wa pili, wa tatu, wa nne, now you start to get the data. The more you start to get the data, the more you are going to update your prior belief. Kwa sababu our prior belief ilikuwa ni kwamba the mean ilikuwa ni 100 according to the prior. But we know the true value is 150. Si ndio? So now we are saying the more you collect the data, why did you start with index 0 and not 1? Kenneth, I think ni au tutawapeleka tuition. Okay, so swali la nani nianze nalo? Why not use value of NI? Okay, NI nimesha explain why NI unaitumia. Ni kwa sababu tu nilikuwa nimeanza pale at 0. Lakini the more you move on, of course you're going to use NI. Why did you start with index at 0? Okay, it's actually very simple, si ndio? Okay, so this is actually the starting point. Kwa sababu, okay, if you are here, si ndio? Which assumption are we making at the, kwa sababu kama good anything, si ndio? Kwa sababu we are assuming this one here is actually the beginning of the period. So the beginning of the period, I mean, you don't know in this part here. You don't know what is the value if you're here. Come back, the first value, we expect it to be to start at around this point here. Maybe think about the starting point of the year. So at the starting point of the year, you don't know. You don't know what is the previous value in that case. Sio, hauna kitu chochote kile. Komake, I have 0 here, and then mwaka wa kwanza una start at that point, and then you just move like that. Ukichange assumption, manake you are assuming that year is recorded at the end of the period. Not sure if that is plausible. Na sidhani kama it make more sense to do that. Of course, the only difference ni kwamba utakuwa una converge faster to the true value. But I'm not sure which one is more robust assumption to make. So for the time being, maybe just try to use, start from 0. Of course, we can take a look, which is more robust assumption in this case here. So it was Kenneth. Yeah, maybe we can take a further look on that. Which one is more plausible assumption? But kwa sababu malaki I'm assuming this one is at the beginning of the period. Kwa if you want to assume at the end of the period, you have to tumia that value kama 114. Of course, that is another assumption. So the question is which one is more plausible assumption in that case. So we can find more about that, Kenneth. Okay. So the other comment is sijaelewa kwa nini unatumia n na sio ni. N na sio ni. No, you guys, we have two things in this case here. Is NIs ambazo mnaziona is this is the number of claims. Aweza kawa ni claims amount. Kwa these are my x's. Yani hizi hapa ni x's. These are my x's. X's. This N I'm using in the credibility factor. This one here is the number of observations. So how many number of observations do you have? It's 1, 2, 3, 4 na kuendelea. So this one here is actually a single observation, single observation, single observation, single observation. Is the number of observations. Now this one here need the number, need the frequency. In the formula here, this one here is not x's. N ni kama x's. We are using this capital N to estimate the mean, and this one here is the number of observations. Does that make sense, Henley? How about inachanganya? This is like your x's kwa sababu utakuja uitumie hizi number unakuja uzitumie unavyotumia kwenye formula. Ukishafika hapa kwamba z x bar plus 1 minus z and then mu. How do you estimate this one here? This is estimated by taking x1 plus x2. What is this x's? Is x's and is n is n1 n2. It's just the notation, but in real sense they actually mean the x's. Tunatumia n kwa sababu we are talking about the claims frequency in this case. No maana tutumia x moja kwa moja, lakini maybe the notation is confusing, but this one here represent the numbers of claims, so the number of observations. Henley, does that make sense? Henley? Okay. Yeah, so mtajaribu ku fill this table here. It's very simple table. Nishatoa hili swali several times. I like this question kwa sababu hapa. So this is actually the information plotted from that table. Maybe it will be much easier to follow from this figure here. So you can see hapa kuna two things. Kuna credibility factor, which is Z, and then you can see hapa tuna zile two assumptions. We have gamma. We see with 101. So hii hapa red ni gamma with two parameters, 100,1. And this one here is a gamma with two parameters, which is 500 and then 5, right? That is actually what we have. So now my question is, can someone tell me why we observe, Z is going up in both cases. In this case and this case, we observe Z is going up. But we see that the rate at which Z is going up is somehow faster in this part here compared to this part here. Okay, so can someone tell me, first of all, why this Z are going up? I've already explained. Initially swali at some point. I think uh last year maybe last year last year na walikosa sana. Uh, so what do you think, guys? Why do you think that thing are going up? Why do you think Z is going up? Why do you think Z is going up? Okay, I can see from because it's increasing function. Excellent, yes. Excellent estimate. Yeah, it's because yes, Sekela, the more the data, the weight. Yes, that is the reason. So the more you collect the data, right? So the more the data you get about the risk itself, we expect Z to go up. Why? Because we know that Z in this framework is given by N divided by N plus beta, right? This beta is actually constant. So the more N goes up, so N goes up, N goes up, and of course we expect Z to go up as well, right? So what does Z going up mean? You can remember from this one, ZX bar plus 1 minus Z and then mu. So Z going up, it means that you are putting more trust in the data from the risk itself, right? So that is what we expect, is an increasing function of N, right? I don't know, niliuliza swali kama hilo, I think. So everything we are discussing here, sio kwa bahati mbaya, you should try to pay attention. Sikuwaga kwenye this test. Ilikuwa ni test gani? Ilikuwa ni special test. Kuna wanafunzi hawakuja, I think. Semester test, I think, is here. Yeah, so I think this was the test. Walalamika, I think ilikuwa na answers anyway. It is totally fairly sana. You have to read. I asked that question. Where is it? Yeah, ili hapa swali. Yeah, it was a very nice question. Ni situation kama hii hapa, kwa sababu you can see credibility estimate. Of course, this one here tutaizungumzia baadaye kidogo, lakini the idea was the same. Just give them the table like this one here, and then they were supposed like to explain. So the assumption is the same. They had a Poisson distribution, and then the assumption kwamba lambda is 160, but this is not actually known. Instead, the initial assumption. Everything is the same like what we have here. Sindio? If you plot Z now, we expect this anyway. Ngoja tuone. Yeah, this was the test last year. Anyway, let me go back here. Okay, so that is correct, right? So I will ask you another question. So why do you think, although both this, so you can see, I mean, this distribution here is going up and this one here is going up. But why do you think the red one is going up in a much faster rate compared to the blue one? So why this one here is going up, this red one going up much faster, sindio? Much faster. Why do you think it's going much faster compared to the blue one? Can someone try? Okay, because the mean of the population is in the red is smaller. Okay, so you are almost there, but that is somehow not true. Why? Because we know the mean of the red one is equal to 100. Is equal to 100 divided by 1, which is 100. And we know the mean of the blue one is also 100 because we know that, we know this is the mean. We know the mean in this case again is 500 divided by 5, which again is 100. So the mean are the same, right? Okay, so I can see from Zoom user because the beta is smaller. Okay, beta is smaller. Beta is smaller. Yes, I think that is could be one of the reasons. So we can say because Z is equal to N divided by N plus beta. And we see that for gamma, we see that um, beta for the first case is equal to 1, and beta for the second case is equal to 5. Yes. I think that could be a reason, right? So because I mean beta equal to 1, and then beta is equal to 5 in that case, right? Yeah, so that could be one of the reasons. But let us think about another reason, right? So the other reason is very important in this kind of models, right? And that reason is actually because of the variance. So someone who said about the mean, I think was very close to what I was looking for, and is all about the variance. Because if you try to estimate the variance, right, you will see that the variance for the lady one, it will be 100 because the variance for Poisson is alpha or beta squares. You see the variance. So alpha is 100 divided by 1, and then the other one is variance of what? Variance of it will be variance itakuwa ni 100 divided by 5 square. Sindio? So which one has a higher variance in this case? Okay, Laverne said the more collateral data, the lower the cleavage factor. Okay, yeah, that is true. But let us try to relate, the variance and what we are seeing here. Because you can see the variance of the lady one is actually this one here. So hivi variance nimepatia kweli. Variance ni alpha over beta square, I think. Kama nimekosea mtaniambia, but I think it's 100. No, this is too large. Alpha over beta square. I think this is the variance, right? Sijakosea variance ya gamma distribution. So it's 100. Na hapo ukiestimate unapata ngapi? Variance hapa. Variance ya this. Yes. Variance unapata ngapi in that second part? 20. Okay, so we get it 20. Okay, thank you. Yeah. So now we can see here. So variance is very important. Variance is very important. So this is the variance, because remember, this is the variance of what is the variance of the prior distribution. Variance of the prior distribution. So the more variability in the prior distribution, the less the weight we can apply, we can place in that data. So you can see, in this part here, you can see that, okay, you can see this one here is 100. So there is more variability in this part here, right? There is more variability in the lead part because of high variance. So the higher the variance, the less the weight in the collateral, and the more the weight in the risk itself. And you can see in this part here, right, which is green, right? Which is green, you can see that the variability is actually 20, is less. If the variability in the collateral is less, or in the prior, in this case here, if it's less, it means that we can put some more weight in the collateral and less in the risk itself. And that is why, even though we observe, both are going up, the rate at which the top one is going up is much faster because the variance of the collateral is higher. If the variance of the collateral or of the prior is higher, it means that we cannot put much weight and much trust in the collateral, meaning that more weight will go to the risk itself. So that is actually the key reason why you're observing, although both are going up, they're not going up at the same rate. So that is actually a very important observation anyway. And you should try, to read and understand all this thing. Kuna some explanation mtaziona, but learn to play with the variance, because the variance, because variability, right? The more the dispersion in your data, the less you can trust your data, right? So that is why the higher the variance, the lower should be, the higher should be Z, right? The higher the variance of the collateral, the higher should be Z. Sindio? Mana, the higher the variance, the less the trust you can put to the collateral, meaning that more weight to the risk itself. Yeah, so I think this is the question, why, right? It's all about the variance, and I want you to understand that. Hii hapa ni almost the same figure, and you can see the number of claims here, right? Now against years. Ile ambayo tulikuwa tuna Z, now I have, the number of claims. And what we are observing actually in this figure ni kwamba is a good thing. Why? Because we are observing that the more, because remember, we know the true value. The true value of lambda is 150. We know is 150. This is the true value, right? True value, this one here. But we know we started it from here. So our prior assumption was around this point here, prior this point. This is the predicted number of a number of claims when we started, right? But we see that the more we move on, the more we collect more data. The more we collect data, the more we are approaching, because you can see now here we reach, let's say, at 149. This is 134. This actually went down a bit, but this one here actually went remain the same. But you can see this number here is at least very close to 50 compared to our prior estimate, because our prior estimate based on the gamma, both of them were 100. It's going 100, go very far from 150, because 150 is the true one. But we see that the more we collect the data, right, the more we incorporate some new data with this prior experience, and we are updating it in such a way that the new estimate here is very close to the true one, right? But now the question, why this is moving at a slower rate, why that is moving at the higher rate? Now again, you go back, to the variance and then to the number of observations, like what we saw before. So I leave that, to you to think about that. And I think is what I've been explaining. Yeah, I think the tighter concentration around the prior mean lower lead to smaller credibility factor. I think nimesha explain all this thing. So I think nilijua nita cover this part here, but I think this should be enough. Isema lecture ni fupi sana, sio? Mkiona hizi slide ni fupi sana, lakini we have a number of things, some good thing, which we can derive from here. How do you want me to continue? Sio mbali sana, we can finish this. Do you want me to continue? We are here. Tumalizie, okay. Kuna watu watakuwa umkene. Okay. So I have 2 yes and 1 no. 2 yes, 1 no. Manake yes wameshinda bado. No, no. Yes, no. No. Okay, I say. So tuishie saa moja. Okay, tuishie saa moja. I think that is a good observation, right? So let us, end at okay, okay, to cover tu muda basi uishe. Some observation hapa mtazisoma kwa sababu the number of estimated claims has been increasing, which indicate changes in underlying risk factors. So the prior has a lower standard deviation compared to this one prior. This suggests a higher confidence in this one here, prior mean estimate. As standard deviation of the prior decreases, the model places more reliance on collateral. So how many slides left? Slide moja, mbili, tatu, nne, tano. Slide tano. Bado slide tano tu. We can finish. Kuna just one part ambayo hapa nitaderive tu one equation, lakini bado slide tano tu ko no emission. A standard deviation of the prior. So you will no sio hiyo nyingine ni comment to yeah. Lamini anasema tumalize, mnaenda wapi? Yeah. Yeah, so you will see hapa, si ndio? Kwa sababu okay, this will be the end of the test. Kwa yani nafutu mmalize this week and then next week. Kwa sababu hapa ni sehemu ndogo kwenye bag. This tighter. Okay, so you will read this one here. Ngoja tu ni nani hapa. Ngoja nimalizie to this part ya kabla ya time yangu haijaisha. Let us denote the okay, so now I said the first model we were trying to model the claims frequency, ndio ilikuwa ni claims frequency, na implement this one here by using Poisson gamma, si ndio? Poisson gamma, na ndo the reason why nilikuwa natumia ni hizi ni axis, si ndio? Lakini I'm using ni kwa sababu nilikuwa na model claims frequency. So we are saying we can also implement the Bayesian credibility by using another approach, which in this case here is normal model. But this normal model is very useful when trying to model the amount, and more specifically when trying to model the aggregated claims, right? So we are saying, okay, let us assume S denotes aggregated claims in a single year from a risk. So we are going to assume that these aggregated claims, they actually follow a normal distribution, right? Where theta is unknown, but the sigma 1 is known. And then we're going to suppose we have a prior belief. For our prior belief in this case here, so suppose our prior information or belief about the fixed values of theta is summarized in the following prior distribution. So theta actually follows like a normal distribution with mean and then this one here. And because this one is prior, you can see that both this one here and this are known values. Okay, so now the question is actually like what we saw before. So the first question asks, without any data from this risk, what is your estimate of the value of theta? Right? Because you will know that theta follows a normal distribution. So if you don't have any data, right? No any data from the risk itself, then the good estimate is actually the mean of the prior distribution, right? So idea ni kama ile ya mwanzo kwamba without any data, then the good thing in this part here is actually the mean of theta, the mean of the prior distribution. But with the mean of the prior distribution, we have a normal distribution here. The mean of the prior distribution is actually mu. So you are done in this part. Siwezi nikuuliza swali rahisi kama hili kwenye mtihani. Swali la mtihani lazima likuchanganye kidogo. But try to understand this. So the idea will be from here, but the mean is actually equal to mu, right? So you are done with that part. You don't have any data. But after correcting the data, now you can update your belief. This was my prior. Now let us combine with what we have now. That is actually the beauty of Bayesian credibility, of Bayesian statistics. So now we are saying, suppose you have observed the risk for any years, and the aggregated claims in successive years are x1, x2 up to xn. Show that the Bayesian estimator of theta with respect to the square errors, just like before, is in the form of credibility estimate. So we are saying, if we combine this normal model, you can rearrange the formulas in such a way that at the end of the day, you end up with a formula which is in credibility formula like what we saw before. So once you understand one thing, I think, the other thing becomes very easy. So please bear with me here. Tunatakiwa to derive hapa formula kubwa kidogo. Somehow big, but simple. So we know that with respect to square error laws, we know the estimator of this theta is going to be the mean of the posterior distribution. So we have to estimate the posterior distribution first of all. But remember, we are combining two normal distributions here, right? So two normal distributions. So our posterior distribution is f of theta, given the data, right, is equal to, kama kawaida, we find the likelihood, which is from I is equal to 1 up to n. We start with the first normal distribution, which is 1 over this one here, I think, normal. Sindio, say the first normal distribution, sindio, theta and then sigma 1 square. So we are going to have the exponent of -1, and then we have x minus mean. Sorry, we don't have x, right? Okay, so we have, let me use x for x minus mean. So what is the mu? The mu is theta divided by sigma. Sigma is sigma 1, and then all this square, right? This is for the likelihood part. And then we have to multiply this one here with the prior, right? So the prior in this case here is this one here, is theta follows a mu and sigma square. So we are going now to multiply with the prior, which again is 1 sigma, and then 2 pi, and then exponent of, this is -1/2, and then we have our x in this part here is theta, right? So theta minus our mean is mu, then divided by sigma 2, and then this one square, and then this one square, right? Okay. Sasa then I'm going to move, so I'm going to take care of the constant. So nita switch kwenda kwenye proportionality like what we did before. And then I'm going to say, okay, so this is very tricky. So we have to take now the exponent here, and then here we have to take the square. No, not yet, sindio? Kwa sababu we know that to take the product kwa tutapata 1/2, and then summation of xi minus theta, like this, sindio? And then sigma 1 square, and then we're going to have -1/2. So this is 1 minus 2 here, sindio? And then we're going to here again, which is theta minus mu, and then divided by sigma 2 square, sindio? And then this part here also square this, and then of course we close this bracket. So now what we are going to do is that we are going to say this is actually proportional to, so I'm going to simplify this one a bit. Okay, so the first part here hapa expand this square ya kwanza, maana itakuwa na summation ya xi square divided by sigma 1 square. So this one is constant kwa sababu haina theta. So it will go, si ndio? So we're going to remain with the second one, ambapo the second one itakuwa ni -1/2 nje, si ndio? And then we are going to have this second one will be -2 a summation of xi, and then theta, and then divided by sigma 1 square. And then we are going to have plus theta 2 divided by sigma 1 square. And then we are going to have this one here, it will be this will be plus it will be plus, so theta square divided by sigma 2, and then minus, so we're going to have 2 mu theta divided by sigma 2 square. Kwa nini mnasoma kozi za kujitesa hivi? Eti kuna watu wanasoma tu sociology huko wafanye ujinga. Yeah, so now we can combine, because we can take out theta, and then we can remain with so we can combine that. Kwa zile zote ambazo ni constant nimeziacha, maana zimekuwa subsumed kwenye this proportionality sign. So now we can say this will be proportional to exponent of -1/2, and then we can have we can combine these things here. So we can say this will be 1 divided by, this is n, yeah? Supposed to be n here, so constant. So we're going to have n divided by sigma 1 square plus 1 divided by sigma 2 square. So this is theta square, and then minus. So we're going to have 2 theta, and then ndani we are going to remain with so it's going to be summation of xi divided by theta 1 square, and then this second part here is going to be plus theta divided by mu divided by sigma 2 square, mu divided by sigma 2 square, like this, and then this. No, maybe nishaondoka actuarial. I say maybe I'm not doing actuarial. Mimi nafanya actuarial kwa sababu hamna walimu wa kuwafundisha. So nyie mnaoendelea na hizi normal, you just carry on with this normal models. So now what we can do here, haiwezekani mnajitesa like this one here. Why? So now we can simplify this because we have to match this one with the normal distribution. So we can take out the this part here. So this part is like the variance, right? So we can say lambda exponent this and then minus 1/2. So we can take out n divided by sigma 1 square plus 1 sigma 2 square, this one here. And then now ndani we can remain with theta square and then minus 2 theta. So in this part now, kwa sababu tutakuwa tuna maanake this part ya chini itakatika, sio? Maana we are going to have something like sigma 2 square summation of xi plus sigma 1 square mu and then divided by this part here itakuja kuwa ni n sigma 2 square and then plus sigma 1 square, call this. Okay, so now here we go, kwa sababu ukiangalia ni kama normal distribution, sio? So you can see here kwamba this is pretty much like this one here is similar like exponent ambayo ni normal distribution. So normal distribution iwe inakuwa ni 2 sigma square and then x minus mu. Maybe let me denote this one here by stars and then this one here by stars. Kwa ni kama normal distribution fulani. Why? Kwa sababu you can see this part here, ndio? This part here ina correspond na this part here. Then na the remaining part here ina correspond na this part. Oh, bado bado hatujaitengeneza. Sorry. Kama mtu amechoka anaweza ka drop hii notes, you can read, yeah. Me I have to finish this thing kwa kweli. Kwanza ina lecture tena is kwa you can read. I will share the notes kama unataka drop now. But I have to finish this. Imebaki sehemu ndogo sana. And then we are going to have proportion exponent of minus 1/2 and then n divided by this one plus 1 over this one here. Sasa hii part ya humu ndani is very tricky thing kwa sababu ni sawa na kuandika theta minus hii party, si ndio? Sawa na kuandika theta minus sigma square summation of xi and then plus sigma 1 square and then mu and then divided by n sigma 2 square and then plus sigma 1 square, si ndio? Sawa na kuandika hii part yote hii afu tukatake the square, kwa sababu ile constant ambayo imebaki, ile constant iliyobaki kule ni constant, kwa hiyo itakuwa subsumed kwenye proportionality sign, kwa hiyo itaondoka, kwa hiyo we don't have to worry about that part again. So hapa now we can compare na the normal distribution. Kwa I'm going to compare with the exponent 1/2 sigma square and then maybe x minus mu. Maybe to differentiate, I'm going to note this one here by star, this one here by star. And manake this part here in align na this part, in align na this part here, afu na this part here in align na this part here. Okay. Oh, what is happening with this part here? Sindio? So now what we are saying this part here ni kwamba sigma this is square ni sawa sawa na, maana we can simplify that part. Kwa itakuwa ni n sigma square plus sigma 1 square divided by no, kwa sababu itapanda juu, sio? So we're going to have sigma 1 square, sigma 2 square, and then divide by n sigma 2 square plus sigma 1 square. And then the mu itakuwa ni sawa na sigma 2 square, sigma 2 square summation of xi plus sigma 1 square mu sigma 1 square mu divided by n sigma square 2, and then plus sigma 1 square. Okay, so now what we can do here ni kwamba we ended here, si ndio? Kwamba show that the Bayesian estimate of theta, tunafahamu kwamba the Bayesian estimate of theta under square error loss is the mean of the posterior distribution, si ndio? So what we need here ni kwamba, we know our distribution is actually a normal distribution, si ndio? Baada ya combine two normal distribution, we end up getting a posterior distribution, which is also a normal distribution, but a normal distribution with two parameters. The variance is this one here, right? And the mean is actually this one here, right? But we know that under square error loss, the estimate of the parameter of interest, which is theta, is actually the mean of the posterior distribution. So the mean of the posterior distribution in this part here, you don't have to compute it, isn't it? You already have. So what we can do, we have to simply prove that this one here is in the form of credibility formula. So we can say now mu theta. So we can say mu theta ni sawa. So I'm going to rearrange kwa sababu hii sehemu ambayo ina summation ya x ndio ile sehemu ambayo inaleta na x bar. So I can write this one here like this is square summation of xi divided by n sigma square plus sigma 1 square plus sigma 1 square mu, and then divided by n sigma square and then plus sigma 1 square. Kwa ukiliarrange hapo utapata this one here is equal to sigma square divided by n sigma 2 square plus sigma 1 square, and then summation of xi, and then plus sigma 1 square divided by n sigma 2 square, and then plus sigma 1 square, and then multiply by mu. So you can see hapa, si ndio? Hapa what we can do, we can multiply this one by n. So divided by, multiply by n over n. So n over n, we are going to get, that part itakuwa ni n sigma square x bar, si ndio? Divided by n sigma square plus sigma 1 square, na hii part iliyobaki itakuwa ni sigma 1 square divided by n sigma 2 square, and then plus sigma 1 square, and then multiply by mu. So you can see now hapa tumesharudi what we wanted, ndio tumesha rearrange kwamba now this formula here is actually in the credibility premium formula ambayo ni 1 minus z x bar plus no, this is z this is z, and then 1 minus z, and then mu. So you can see this is your z, and then this one here is 1 minus z, and then you are done, right? So if you have a normal model, then your z is equal to n sigma square divided by n sigma 2 square, and then plus sigma 1 square, like this. So yes, so we can rearrange, the normal model in the Z formula like what we had before. Don't worry about this one here. It's just simple, just to rearrange this thing. But remember hapa proportionality sign ina matter sana. Maana nilikuwa natoa hizi term kubwa zote naziweka zote ambazo ni constant, zote zinakuwa subsumed na proportionality sign. So just to finalize this one here ni kwamba Z kwenye normal model ni kama tu ile z ya mwanzo kwamba z will always be between 0 and 1. Hii hapa haibadiliki, si ndio? Is the property of the credibility factor. As for a fixed n, and sigma 1, z is an increasing function of sigma 2. So I want you to understand why this thing makes sense. Kwa sababu remember sigma 2, what is sigma 2 hapa kwenye assumption yetu? Sigma 2 ukiangalia hapa, sigma 2 ni the variance of the prior distribution. So if the variance of the prior distribution goes up, we expect z to go up. Si ndio? Why? Kwa sababu the more the variability your collateral are, the more the variability the prior is, it means that we cannot trust the prior. So if we cannot trust the prior, it means that we have to put more weight on the data. And that is why the higher the variance of the prior, the higher your Z will be. So your Z will be going up, right? So it's an increasing function of the variance of the prior. So where is it? It's here, right? So it's an increasing function of the variance of the prior. And then for a fixed n and sigma, Z is a decreasing function of sigma 1. So what is sigma 1 based on the assumption? So sigma 1 is actually the variability is the variability of the in the risk itself, because we are assuming this one here. So we are assuming this one here that the data, right, the aggregated claims in this case here, they follow normal distribution with mu theta and the variance is sigma 1 square, right? So if sigma 1 square is high, one estimate, let's say in 50, the other estimate in 1 million. The other estimate, let's say, is 60. The other estimate, let's say, is 2 billion. For instance, that is extreme, but that is actually the case. So if, I mean, there is high variability in the data like that, how can you trust the mean anyway? Cindy, I mean, you can't because of this high variability. So if there is high variability in the data from the risk itself, your Z should be small, meaning that we cannot trust the data from the risk itself. Instead, we have to trust more the collateral, right? So you will find these properties will, so that is an increasing function of sigma 2, but this one is a decreasing function of sigma 1, right? So I want you to understand why these are the cases. Of course, I mean, this is actually just the explanation of what we covered. And I just want to end with these two slides here, right? So for aggregated claims, I think will be after this lecture. So it's aggregated claims, and of course we are combining the models. But it doesn't mean that this one is a good model, right? Right, Esme? The reason why we are covering these models is because at least we can rearrange these formulas and demonstrate that we can have a credibility formula out of this model, right? But does not mean that it's a good model, right? Maybe it's not a good model, right? The only reason is that we can rearrange this formula. Not all models can be rearranged, right? So to demonstrate the idea, right, of course, we have to do that, right? But it does not imply that normal model is a good model for modeling aggregated claims. By the way, you will see the model, which we are going to cover next week. I mean, for aggregated claims, I mean, we don't have the normal model, right? I think the main idea here is just, I mean, to demonstrate this thing. But again, you can get, I mean, a very close approximation, maybe for aggregated claims. The model which we covered in the first week, it was for individual claims, right? Not the aggregated claims. I will explain in details what it actually means when we say aggregated claims and individual claims, which is actually the topic for next week anyway. But maybe for the time being, I mean, just using this model to demonstrate the idea about Bayesian credibility does not mean that this one is a good model, right? I mean, probably it's because we can rearrange it, because not all models can be rearranged in the credibility form like what we saw before, right? But how powerful this model is in modeling aggregated claims, I don't think it was a good model. Sarah asked me. We'll discuss that, I mean, again in next week, because next week I will cover aggregated claim models for aggregated claims or short-term contracts. Ask me. Okay, great. So that's it, guys. Thank you for coming, and I wish you all the best. So we are done with credibility, and so get ready for the test. Or text in our voice here. Yes. So this is the end because you can see here, yeah, we are done, right? Yeah, so we are done with credibility theory. So just get ready for the test now. The test will be too tough. It will not be easy. It will feel like UE. For that is the comment I was getting last year, that the UE you gave us was too long because we used to short tests where tests are normally like we were. I mean, the questions, maybe you ended up with 2 questions or 1 question. I don't know. So that is not how I compose my test, right? So my tests typically are very comprehensive. So try to read and understand and stuff like that. Otherwise, you'll come back with the same comment that, oh, your test was too long, your tests feel like you, the time was not enough. We expected question to solve, you give us question to explain, which I think, I mean, they don't matter much, right? So just get ready for the test. So that said, enjoy your weekend, and I look forward to seeing you next week. So thank you, Irene. Uh, okay, thank you, Berisima. Enjoy your week. Okay, bye, Yana. Thank you, Kenneth. Uh, uh, Kenneth, unaonyesha kwamba I'm serious. Sijaelewa, I'm serious, you know. Kenneth, serious on what? Kenneth, Kenneth, I don't understand. Are you serious? What do you mean, are you serious? Are you serious going to test? No, the test will be tough. I'm not lying. The test will be too tough. Too tough. The test will not be simple. Kutua tunaogopa tu, tutawambia nini? Degree haiwezi ikakuwa mwanafunzi wa actuarial. Wanafunzi wa actuarial ndo um, just after why too tough. No, it will be too tough kwa sababu I don't know you are used to, kwa sababu the challenge last year ilikuwa ni experience. So walikuwa na experience ya test kichwani kwamba test inakuja na maswali mawili, maswali mawili yana solve sijui stuff like that. My test can come with 5 pages, na 4 questions, or even 5, or even, I mean, 5 questions. So just usiwe na ile kitu ya tutakuwa na 2 questions and stuff like that. Tutakuwa na maswali mafupi. No. The questions yani kama tuchukua UE afu ikate katikati. So that will be the test. So the test will be too long. So this time at least niwaambie kwa sababu ndio feedback ndio ipata last year kwamba the test was too long. The test was ilikuwa na maswali ya kuexplain mengi kuliko ya kusolve. Test ya isovi, yani muda hautoshi yani. Sijai kupata comment hata siku moja kwamba ya muda unatosha. So in case of time, just get ready for that. How long will the test take? Test naweza nikakupa tu hata dakika 40, lakini probably the test for 2 hours. Ukiingia kwenye test, I don't want you to think, I just want you to still sit down and write. Ukishaanza kufikiria tu, then the time will not be enough. So the test can be only for 40 minutes, 45. But you don't have to think. Kwa sababu nilikuwa naambiwa kwamba pia we needed time to think. You don't have to think. Ukishaingia mna ndani, you just have to start writing. The moment you start to think, then you are gone. That is what I can say. So you have seen the sample test. Pia I believe we will have some access to the past paper waliofanya wenzenu. Kwa you can take the nature of the questions. Yeah, hakuna kufikiria. So there is no time to think. Yani ukishaingia ndani, you just get ready to write. Yeah. Kwa sababu maswali ni yale, ni maswali haya. Kwa don't expect you to spend a lot of time thinking mle ndani. So mtihani kugumu to think. Kama mtihani kugumu, hii ndo good exercise. Kwa sababu you have to exercise, to do some exercise before going to the street. So tough questions, they will prepare you for the tough life out there. So Mwemezi, so get ready for that. Yeah, I'm joking, but just get ready for the test. It just be simple kama umesoma. Lakini kama hujasoma, kama you are trying to predict, that is not a good idea. Yeah, so let me stop here and enjoy your weekend. So we'll stop here and end the meeting.